Hello. So as I said at the end of the earlier video, we would like to show that two events are independent. To do that, you need to prove one of those two equations, right? And we are going to use the first equation to prove independence. The first method is to show this equality. But there are actually two equalities. Like there are three guys and they are all the same, but you don't need to calculate all three. Just choose any two of them. There are three probabilities. Choose any two of them, and if they are equal, then automatically the other follows. So what you need to do is to show one of these three equalities. Then you prove the independence, right? So, and you know how to calculate unconditional probability. You know how to calculate conditional probability. If you calculate two of them, and then that's it. But what many students are confused is this. Remember the role of B is condition. So when you compare unconditional probability of A, what you change is the condition. By changing the condition, you have to see the probability remains the same or not. So what you change is the condition, but the main event must be the same in all the probabilities, right? The main event of interest is all A, so you only change the condition. That's the point. So let's come back to this data, example data. We need to test any of these six equalities. If you can prove one of these six, that's it. That's enough. So the difference is the first three equations, the first three equalities use S as the main event of interest. And the other three equalities use T as the main event. So choose the main event and change the condition and compare. Okay, let's see what we do. Yeah, effect. I forgot to show the effect. So for example, it doesn't matter what you do, but I'm going to just show you this. So no matter what you do, just choose the easiest way, the simplest possible probabilities to calculate. To see this, first I'm going to calculate unconditional probability. Simple. Unconditional probability of high tuition. This event includes these two outcomes. So probability is 45%. And conditional probability. Among high salary earners, high tuition is 11.25%, which is again 45%. So they are equal. We have proved it. Then this proof implies those two S and T are independent. That's it. So that's one way to verify independence. And now I'm going to show you the second method. The second method is based on the special multiplication rule. Special multiplication rule takes this form. You have to prove this equality. And in here, we have to calculate this probability, one, and this probability, and this probability. You need three probabilities to prove this equality. But still, this approach may be easier than what we have done, than method 1, depending on how data and information are given. So, see, in our example, I'm going to calculate probability S intersection T first, which is the left-hand side, right? Intersection probability is only this probability because it has only one outcome, 11.25%, and then calculate the probability of each event, S and T. which is pretty straightforward. S includes these two outcomes. T includes these two outcomes. So their probabilities are 25 and 45. So we obtained three probabilities. Now, to prove this equality, the right-hand side needs a multiplication. So multiply those unconditional probabilities. S times T is this. And remember, percentage may confuse you, so try to avoid using percentage. Use fraction or like decimal, whatever. Use number, not percentage. So 0.25 times 0.45 equals 11.25, which equals the probability of intersection, right? So we proved that the special multiplication rule holds. That implies, again, the independence is satisfied. The independence holds. So as a result, we can prove the events are statistically independent. So as I showed you, there are two different approaches to check statistical independent, and you just need to show the equality. In case if you calculate those probabilities and you find they are different, then simply the conclusion is the other way. If they were different, then two events are not independent, or two events are dependent. So checking independence is like simple. You just need to calculate the required probabilities. Okay, so in many videos, maybe this is the sixth video, we defined conditional probability and how to use the conditional probability, and we also defined independence and how to verify it. So in the next, so far, the main theme is that when you have data or when you have probability distribution table, we learned how to use those probability distribution table to understand conditional probability. But from the next video, we are going to go the other way. So in many cases actually, the data or information are given in terms of conditional probabilities. So sometimes you only have conditional probabilities, and from there you'd like to recover unconditional probability. Then the method is a little bit tricky, so that's what we are going to do in the following videos. So keep watching, and thank you for watching so far. See you later.